Welcome to the HiRSE-Seminar series on research software engineering in Helmholtz and beyond.
So thanks for the introduction, and I will start and give a short overview of the HELIPORT project we started a few years ago. It is an agency project, and after me, I give over to Stefan, who explains a little bit a real scientific experiment carried out with HELIPORT, and then afterwards David with a few thoughts on HiRSE and HELIPORT. So our open research project guidance system has the name HELIPORT. We developed it starting a few years ago, and I cannot change my slides at this one. Yeah, so our challenge is in the end that we are a large research center, a Helmholtz center. We have 1,500 employees, 700 scientists, and the main challenge is that we have 3 different research fields. So we have energy, health, and matter. Most of the data comes from the field matter, and we as central IT are more or less responsible for every scientist at HZTR with all the different projects and all the different specialties and data management challenges. We have large facility, our Elbe Center for High Power Radiation Sources, where also the most of our real data is created. We have also a highly magnetic field laboratory and an ion beam center, and so many other smaller experiments, and we have to bring all of them to our central data management ecosystem. That is the plan in the end. And our challenge is also the end-to-end digital data lifecycle. So from the proposal and the first data generated to the data publication and real scientific publication in the end of the process. So we support many of these steps of our different research experiments with tools. So we have an electronic lab book, we have interactive analysis, publication of data sets, scientific workflow management, and also the generation of handles and the management of the overall experiment. So typically we start with a proposal, but only on our large-scale infrastructure devices. And then afterwards, we need a data management plan, not at the moment, but maybe in the future. Then the collection process of data starts, the real experiment, then analysis and so on, derived data sets, and then everything has to be archived and finally published. And in an ideal world, we can then search on our data and reuse it for new experiments. That is the idea. And we need in the end a uniform and smooth access between all these different services and systems involved in our ecosystem to make research and the work with the digital research projects easier for our scientists, especially for our visiting scientists who come here to measure things and then they disappear. And they should need, or they has to need our infrastructure, and they has also to store the data on our infrastructure, so they should know about the infrastructure. And we need a documentation of everything. So I started in 2019 to write a big write a big picture on all our services. There are so many different services. I have here an overview of them. And the IT infrastructure is really complex. These are only the services inside HZTR. And our scientists and also the visiting scientists often don't know what happens here, what is available, and how they can use these resources. So we realized that we need an overall data management guidance system. That was back in 2019. And then there was, I think in 2020, the call for the first HMC projects. And in the end, when we have something here in this ecosystem, it is primarily metadata. So we start writing the proposal. And since then, our data management guidance system has the name HELIPORT for Helmholtz Scientific Project Workflow Platform. And hopefully we can help our scientists to keep track of the research products and to also discover the services we provide inside HZTR. And in the future, we hopefully can provide all this information in a knowledge graph and combine our knowledge graph with different knowledge graphs around Helmholtz. That is an idea for maybe a next project, HHC, or whatever we need. So the idea of HELIPORT is, in the end, it is this guidance system on top of everything, and we want to combine there or create there an overall metadata scheme where every subsystem is referenced in some way, and then, that is important part, where we also reference all the subsystems used. Here, for instance, the real data publication on the left side, the software publication can also be addressed in HELIPORT to find it, and the typically starting point is a scientific proposal coming in from the scientist. So another motivation from the user perspective, I said we are the central IT department, and there are so many questions from our scientists, and most important are during the last time, how can we automate recurring processes and keep track of the status and the final data products? So that was important for us to show where the data comes from or where the data is located. Another important question is how we can bring new team members or external scientists to our project lifecycle and the associated services and tools. So a simple add a new team member button in HELIPORT is really perfect to show where everything is located, every system, the data sets, and so on. And how we can grant access to both of them, and where can we publish the final data sets. So we have subsystems for publications, but we have to show all these things to our scientists. And from our IT, the main questions are, what are the necessary steps towards a full, comprehensible, and fair research experiment, and how we can ensure data provenance. And on the long term, how we can reduce computations and save energy. So when we show in HELIPORT that there was a computation on our cluster, every team member knows that, and rerun is not necessary. So we started the HMC proposal, HELIPORT. The projects in our first HMC project were HZDR, Helmholtz Institute Jena, and Research Center Jülich. It was funded by HMC, and yeah, this is the result, what you see here on top of the page. It is the overall idea to show every subsystem involved in the project. And we can export everything here on the left side to a metadata scheme, and then we have more or less provenance. And we can also export this to a known scheme, maybe on schema.org, research project, and so on. The time scale for the HELIPORT project was in the end 2 years, so from 21 to 23. At the end, we had the experiments at our facility, TU Elbe, and at Helmholtz Institute Jena, Polaris, and HELIPORT is in the end a nice website, a web page which brings everything together. Stefan will show that in a few moments. Our timeline for the first HELIPORT project was, in the end, the initial version was ready in June. Then the first project plan was also ready in August 2020, so we were well prepared. And then came a lot of improvements, modular structure. Then the official start, the project was the HMC project, and additional apps. And in 2023, last year, we had our first HELIPORT community workshop at HZDR, and there we had members from our center, from Jülich, GSI, Jena, and GFZ in Potsdam. That was our workshop here at HZDR. So that was a real live workshop, and we visited also one of our experiments here. And we have a community website. We are still working on that. We still try to improve it. It is still the version from 2021, but there you can find overall information on the project, also documentation, resources, news and events, and also we provide there also access to our HZDR HELIPORT instance, And there it is now possible to log in via Helmholtz ID and then to access HELIPORT. But it is useful for many people, yes, but not for everybody, because HELIPORT is still a system deep integrated into the HZDR infrastructure. So at many points, you also need an HZDR node. But for a first introduction, I think it is a good starting point in the end. The main features, it's a long list, but I think the important things are we have a wonderful REST API. Now authentication via Helmholtz ID is also possible. The to-dos are we need a better integration of our HPC resources at HZDR. And I think most of the screenshots here, Stefan will show most of them in his talk. And then that was my short introduction. What is HELIPORT from the project level, from the intention where we started to develop it? And yes, the name HELIPORT is maybe a good choice because HELIPORT, the helicopter flying above everything and then looking down to the research area, to the research landscape, and to all involved systems. So that was an idea, and hopefully this leads us to a full, comprehensible, and fair research project. And now I will hand over to Stefan. I think questions after all three talks. So, Stefan.
Okay, yes. So I will describe how we used HELIPORT to document a beam time at the GLB facility. Actually, this was a beam time about 2 years ago, where we wanted to characterize a detector system in high flux gamma background. So this was germanium and the lanthanum bromide detector, which will be set up in the future at the Mu2E experiment at Fermilab, which is now under construction. And just to give a little bit of context, so the GLB is the photon beam line at HZDR's ELBE Center for High Power Radiation, and you see this here on the right. So the primary electron beam is hitting a niobium foil target and producing pulsed Bremsstrahlung flashes, and there's a magnet that sweeps away the remaining charged particles, so you have a pure gamma or photon beam, and then you can expose your detectors to this beam, and it turns out that the beam characteristics are very similar to what we will expect at the Mu2E experiment. So this was very good to test these detectors, which will be used for the normalization of this Mu2E experiment. So this is a user facility, this GLB beamline. So a proposal was handed in with these numbers through the GATE proposal management system at HZDR, and then a panel, the scientific advisory committee, decided about the beam time and got it. So essentially, 2 of these detectors, as you can see, were irradiated behind a lead wall with a small hole of 1 square centimeter to shield a little bit of the radiation. And this was just to show that these detectors can perform in the environment that we expect at the Mu2E experiment, which we reproduced here at with the GLB beamline. The detectors were provided by one was provided by a group in the US, and the other was from the UK. And the US group was remotely connected during the beam time. The UK group was on site. And you see us here in the counting room. We have this big screen where we had a Zoom session open around the clock, 24 hours for this about 3 days. And so we could continuously discuss with our US colleagues, and we had also in the cave itself, we had cameras and whatever. So when we were doing setups, they were always connected. But then in the end, we needed to store all the information on who was collaborating and the documentation and the computer codes and the data location, both on disk and the archives, and then in the publications in one place. And that's, of course, can be very nicely done with HELIPORT. So here you see now the overall overview of the project. So you see these kind of 4 different categories: systems, resources, automation, and results. So the names are a little bit under discussion, but I will more or less go through them later on. But first, the first important step is what Oliver already mentioned, that the HELIPORT can interface to our gate proposal management system, which means that since in the proposal a lot of information is already there, we can automatically import that, like title, the authors, the description, beam time schedule, and which research facility is used. So you just connect from your HELIPORT project and link your gate proposal project, and then it's automatically imported things like who was the proposer, the co-proposers, and a list of experimentalists and the abstract and so on. So you don't need to type this in twice, so you have that. And then of course you can add more people and more things. And for example, what you want to document is, in a way, you want to keep track where your documentation is, and also the code repositories for computing code that you might want to use. So this is done in this systems category. And essentially what we had two logbooks, one for preparation and one for the run logbook on Headstock, Daisy. And then we had a cloud folder, and you just link this here. And if you click on the open button, I mean, it will actually open, provided that there is a predefined login method in HELIPORT defined, which you can be based on SSH token, username and password, or whatever. So it's also essentially you can also kind of create a key and pass this on to our HPC center. And then with this login, all the members of the project can essentially access the resources through this predefined login. And this is very valuable because, especially for external people, it's really a hassle to set them up on our HPC systems. And through this HELIPORT, they can get at least a basic access to the devices, to the storage. And the same for the version control. So here we have kind of one GitHub project and one project on our GitLab, which are some computer codes which were used to analyze the data, part of the data. And so this can be easily linked from HELIPORT. And through this authentication, you can also give access to these codes to the external users, which are part of your HELIPORT project. And then, of course, you want to keep track of where your actually raw data sits. And all these folders and files on our HPC cluster can be registered in HELIPORT as a data source. And each project member, again, has a read-only access. But I mean, this is better than nothing, of course, to the files and folders using the stored login credential of the HELIPORT project. Unfortunately, this feature of making the data immediately accessible was not yet implemented at the time of the experiment. So we had to go through our cloud system to transfer the files so that our US colleagues could have a quick look at them and tell us if we are going in the right direction or not. But it was also possible, but it would have been, of course, much nicer if this at the time was already present in HELIPORT. But now it is, and for future beam times, we can make use of that. And then, of course, I mean, you can click on these folders, and then you can browse all the folder structure. And at a certain point, when you arrive at the file level, you can also download the files through HELIPORT. And then in the end, of course, there are the results, namely publications. And these are simply links to software or journal publications. So here we have one data publication in our Rodare system, which you can access from here. And then recently also one of our UK colleagues submitted his PhD thesis, which we can also access from here. And the actual paper is now under review and should be also pushed to the archive soon. So then this will be added here. And this is, of course, very convenient. And of course, we also archive our data with on our tape system here at HZDR. And here we are still working on a better implementation of connecting HELIPORT to the archive process. But at least here we have the archive numbers, so we can refer to that once we would need to put the data back on disk. I mean, at the moment they are still there, but who knows what will be in 5 or 10 years, right? Okay, so conclusions. I mean, we have used this HELIPORT system to document an experimental beam time with international and also remote participation at the GLB beamline. And this is very important to have a fair and comprehensible documentation of the research project. The feature of making the data immediately accessible was not there at the time, but now it is. I mean, also from this experience which we had at the beam time, this led to this feature. We have not used the workflow capabilities, so I did not say anything about this, like starting kind of a job on our HPC systems through HELIPORT. This is also possible, but we have not used this in this project at the time. And nevertheless, this project has been and is still used as a working example, use case to further develop, improve, and test all the features of HELIPORT. And I think many features which are now in HELIPORT have actually come from this experience. Yeah, so it was very beneficial that not only that I'm part of, let's say, the HELIPORT team, or at least I'm sitting in the same room like with two of the developers, and at the same time I'm a research scientist here and working on the beam times and on the experiments. So this is a very good interface, and I think the project HELIPORT has very much benefited from that, I hope. Okay, that's from my side, and now I hand over to, hey, oh, it took exactly 10 minutes, I don't know.
Okay, thank you. So I would like to talk about, I just give a short little overview from a technical perspective on how HELIPORT works, and then talk about some current developments and challenges. Okay, so this is an overview of the of HELIPORT and the the infrastructure that it interfaces with. So HELIPORT is a Django project. Django is one of the most well-established Python web frameworks, and you can find all kinds of connections to resources that you would find in maybe any other web application. For example, of course, there's a database in the background. We have a message broker and task queues and so on. But as Oliver already mentioned, HELIPORT is also interacts with a lot of the research institute specific infrastructure. So for example, in our case, this would be the proposal system gate. It would be for example, a GitLab instance and so on. And so we would typically expect that if you want to use HELIPORT, again, as Oliver mentioned, you can try out things on our instance, but to get a better integration with your local resources, you would probably have a HELIPORT instance at your research institute as well. Features are added to HELIPORT via plugins. These are just standard Django apps, which is the Django the infrastructure that Django provides to build features that are reusable. And usually we have one Django app that interacts with one system or that interacts with one kind of system. For example, the gate connection is realized in one app. And another thing would be, for example, SSH connections to remote machines. This is also implemented as a machine, as a app. Then the HELIPORT core app defines certain interfaces which you can use in apps, for example, to hook into the project graph that was shown already, or into the search feature, as well as into the project metadata serialization. And this is now a bit of a call to action. You can write your own apps if you would like. You can find the HELIPORT source code on the Helmholtz code base, or you can reach out to us via any of the means on the website that Oliver already showed. Okay, so this is an overview of a sample project that you can create in HELIPORT, which already uses a lot of the features that are available. Some of the things, for example, the data management plan and share LaTeX, for example, these are just at the at current stage, these are just links to certain systems. But other apps like the workflow integration, for example, these are more fleshed out with more features available. And yeah, I will now go into some of these features. The first thing that I want to talk about is a bit from the a first example from the HELIPORT inception, so to say. We wanted to reuse proposal metadata because we noticed that people who had a proposal at HZDR for a beam time, for example, they would already have all these metadata about their projects in the gate system. And once it would come to a data publication, for example, after the experiment, they would all need to enter these metadata again when doing a data publication, for example. And we wanted to provide an improvement over that so that you don't have to enter things twice and potentially make errors. So the first or one of the first workflows that we implemented in HELIPORT is the possibility to read proposal metadata from the Gate API that was especially created on our request because it didn't exist before this. Then you can register your data sources and tag them with a publish tag, and then run an integrated publication workflow in the background to automatically generate a data publication on our local publication system, Rodave. The next feature I want to talk about are landing pages, because these are what we hope could be a potential entry point for a lot of people to interact with HELIPORT, because these landing pages, they exist for every resource that you can register in HELIPORT, and all of them have persistent identifiers. In our case, these are handled, but other systems could be implemented as well that resolve to this landing page. The landing pages display certain metadata, some semantic properties, which you can see in the example on the right here, that this is refers to an archival document. These are the tape archives that Stefan mentioned. In this example, you don't see a lot because there are different visibility levels, and you can choose how much information you want to show to the public. But we also, on top of this, we want to allow people to show more specific, research area specific properties here. And the main information you can find on this page are kind of bibliographic metadata, for example, about the owner of the resource. Also, the landing pages provide metadata export in different formats. One would be data site, and another would be various serialization formats of RDF. An example for this you can see on the right in Turtle syntax. And the landing pages also support content negotiation, which makes them machine-readable, so that you can access them like an API, for example, and fetch metadata about resources from there. Landing pages actually exist for all digital objects, which are our fundamental type for resources in HELIPORT. And these can be used as a base class for any type of resource that you would like to implement. Digital objects encapsulate certain generic metadata, as I mentioned, for example, the owner, co-owners, label, and description. But you can also add certain arbitrary metadata in a triple format if you would like. But this is at the moment a manual process and a bit error prone. So we would like to, in the future, generate more of this automatically, because some of the implicit metadata, I call this here implicit. For example, if you add an archive data set, for example, this is implicitly of the type archival document, but this is currently not usable within HELIPORT, so we want to work on that. We also want to advance our implementation of digital objects more towards the fair digital object specification. Digital objects can be arranged in graphs, digital object graphs, and they show the relations between digital objects. And this can be used to visualize certain facets of an experiment. For example, computational workflows, the software that was used, and the output data sets of this workflow. This is an example you can see on the right here. Another thing would be, for example, to visualize owners, members, and contributors of projects, or data sets and how they evolve into data publications and archives. This is also currently implemented, or these are also currently created manually, which means that the possibilities aren't necessarily clear to the users at the moment. So we want to add some default interesting views that people can use directly. And a first use case that we're currently working on is to visualize workflow metadata from a snake-make workflow for pick on GPU, which is a particle in cell simulation code, where a master student currently implements the snake-make workflow. And we want to transform the metadata into workflow forever ontology metadata, and then display this in HELIPORT. Another thing that we recently looked at is the idea of documenting ML experiments, and I brought here an example from our local Helmholtz AI unit, who develop, for example, among other things, surrogate models and virtual diagnostics for certain stages of particle accelerators. And our idea was that we could use HELIPORT to document this in a better way than purely machine learning focused tools could. For example, we can use HELIPORT to describe these digital objects that are created in different domains. For example, in the ML domain, we can describe them. In the data provenance domain, we can describe the computational workflows and so on. This also would allow us to have improved data and model provenance throughout the entire project. For example, at these stages where we often talk about digital twins, where real-life experiments and simulations come together. And this would also allow us to identify upstream changes that affect how the ML model was trained, and also identify benefits. For example, if some model suggested better parameters which improve the beam. And we could, for example, create automatically dataset and model cards or visualizations for publications. And for this, we had a look at some machine learning vocabularies and ontologies, as well as some associated tools. And I already posed this question at the HiRSE conference recently. If any of you have already made some experiences with any of these vocabularies or ontologies, please feel free to reach out to see if we can work on this together, maybe. And with that, I would like to thank you for your attention, and we are happy to answer any questions.
Thank you for watching our seminar. Please check out the slides on Zenodo linked below, and see you next time.